You are going to debunk general relativity if you think you can measure an orbit. I'm just letting you know right now.
Well, they measured orbits long before GR.
Yeah, you're just straw manning.
Like I would
No,
say,
that's not measuring an orbit, dude. That's measuring where something is in the sky. You can't measure the orbit because.
But, no,
yes, we can because we can predict where it will be and when. How do you do that without measuring?
You can measure where something's going to be in the sky.
How do you predict where Mars will be without measuring the orbit?
And then talk when he responds?
That's not okay. That wasn't what he's saying, Toad. What he's saying is you can measure like the angle that a star will appear in the sky, but by doing that, you're not measuring an orbit. I agree with Jeremy on that.
Yeah. You can't measure an orbit, bro. Just according to general relativity and all the stuff we've laid out, they tried to measure our orbit and figured out it's impossible to measure an orbit. So you saying we can measure an orbit is
you're talking
crazy.
about our orbit, and you're trying to talk about our orbit again, and I'm saying we can measure other orbits. I would agree with you that measuring our Earth's orbit will be troublesome, but measuring others, yeah, we can do that because of our location.
The problem is, though, you're onto a new problem now with trying to measure other things' orbits. The problem that you're going to encounter here is that at the highest level of PhDs, they don't know if anything's moving. If you go crash your car into a tree, the highest level, I know this is funny, right? This sounds goofy, but this is the highest level of PhDs will tell you that they don't know if the car or the tree was moving. They have no idea what's moving. So you saying you're measuring an orbit, that's neat. That sounds neat. But these other guys, the actual PhDs, they don't even know if that's moving or not.
All right. So in other words, you're just taking things so far up there that nothing really matters. You're like going beyond the scope of this conversation just to try to prove a point and win a stupid argument.
I went to the highest level of PhD-ness.
Okay, and that is not relevant to this discussion. That's like, Newtonian physics work. Newtonian physics are perfect for understanding the world we live in now, the Earth interactions, all of it. But if you want to understand more, then you're going to need to study general relativity.
Okay, so the thing is, the Newton thing.
You don't need to study Einsteinian physics to understand things happening on Earth.
We're talking about orbits. If you want to stick with Newtonian things, we're not orbiting because they couldn't measure the orbit. And according to Newton, you would have been able to measure the orbit. That's why they had to bring relativity in. You can't stick with Newton. You have to go with Einstein because we're talking about orbits now. If you want to stick with Newton, we're not orbiting.
I was talking about just in general in day-to-day life. You can go by Newton's laws, but if you're going to be studying, as we are now, discussing orbits, then we have to move into Einsteinian territory.
So the
PhDs,
which is where
the current PhDs, that discussion is beyond Einstein level and is therefore not relevant to what we are discussing right now.
It's not beyond. These guys aren't beyond Einstein level. Einstein level is you don't know what's moving. That is Einstein level.
No, right Einstein didn't say that. Or if you can show me where Einstein said that.
Einstein definitely, please. Einstein definitely said that. He used the example of a guy falling. It's just as likely that the sidewalk came up to smack him as his head did to hit the ground. Einstein definitely said that. These guys are on the same level of PhDs. These guys are on the same level. I don't know. Can anyone Google that real quick?
I mean, because that description there is easily explained as just gravity. The mass of the man is moving towards the mass of the Earth, and both are slightly attracting each other.
Yeah, but you don't know which one
overall, it's the man that's being attracted to the Earth more than the Earth's being attracted to the man. So
no, according to Einstein, though, you don't know which one actually moved. Was it the guy that fell down, or was it
they're both moving? The Earth just very, very slightly. It's simple. You're straw manning this.
I'm not straw manning anything. I'm telling you right now, at the highest level of PhD, you looking at something in the sky and saying it's moving is absolutely ridiculous. They don't even know if a car and a tree that have crashed into each other, they don't know which one was moving on Earth. they're in the highest level of PhD is in no position to say if anything's moving or not. You can't measure an orbit. They've already done it. You wanted to stick with Newton for here on Earth. You have to go to Einstein for the orbit. And according to that, they never know what's moving. So you're not measuring an orbit by looking at Mars.
Yeah, this is all just cope and just straw manning.
I'm not straw manning anything.
Come on.
I'm literally not straw. What was the straw man?
It's the thing you've been saying repeatedly that
give me it. Give me the straw man.
That you can't measure orbits because you literally can, and we literally do.
Nope, you can't measure an orbit.
We can measure when the Halley's Comet will be visible in the sky. We can measure when asteroids are going to come close to Earth and exactly calculate roughly when, if anything, they will impact us. We can calculate these things.
We couldn't do it.
You're going all esoteric by saying that
this guy always stops and then picks it back up. Two people go to talk and then he'll start talking again. This is brilliant.
And you're going esoteric by saying nothing is moving.
That's not esoteric. That is the highest level. That's the highest. Bro, just stop for a second. It's not esoteric. That's your PhD mainstream science. That's hardcore science right there. You never know what's moving.
But you do understand that it sounds esoteric compared to...
Dude, I let you do your whole thing. Bro, just stop, man.
Because you've already said this, and it doesn't mean you've said it before. You'll say it again, and it doesn't change what has been said before. What I've just
you real quick, okay? Okay, you can't just temporarily, just so I can get my thought out, please. I'll unmute you right away after. You can't look at something in the sky and say it's orbiting because you'd have to be moving, and they don't even know what's moving when they look at something. In fact, even asking what's actually moving is ridiculous. So they have no idea what's moving anywhere. We can't measure it on Earth because of Michelson-Morley. You can't have Newtonian. You got to stick to Einstein. This is just your own. This is mainstream science. Like, this isn't esoteric anything. This isn't mysticism. This is mainstream science.
Okay, and you've explained that repeatedly, and it doesn't change anything I have said, and you've not explained how it does. So your whole point there is irrelevant.
You're not rebutting. You're not rebutting.
Yes, I am. Yes, I am.
Give me your rebuttal. What's your rebuttal?
I already explained how mass attracts mass, and that, yes, we do calculate things. You've not addressed that. You've just said, in the highest level of science, we can't. When we do, like, that's irrelevant to this.
It's not irrelevant. We're talking about things moving, and in the highest level of mainstream science, they don't know what's moving. So you're not going to be looking at anything and say we're measuring.
Then why is it relevant? How is that relevant to this level?
Just stop, man. Yo, my man, stop interrupting people. It's fucking annoying, dude. Please, can you do it or not? You know what? I'm gonna just back out and mod. I'm gonna just mod. Go ahead. That's fucking obnoxious, man. Come on.
I mean, you're being annoying by repeating the same thing over and over.
You're interrupting me every time. I don't care, dude. You're not addressing it.
Yes, I did.
You're not addressing it, dude.
We both basically did the same thing, to be perfectly honest.
Phinky, did he address the points I made? Phinky. This guy's on your side, Phinky.
Phinky,
go on, cuz.
All right, he left. You didn't address anything I said. You can't measure an orbit. There's no way to measure an orbit.
I did.
In the mainstream model, there's literally no way to measure an orbit.
And you're ignoring the fact that we literally do. How we predict everything.
Prediction.
We do.
Where you think it's going to be in the sky.
And you're ignoring that.
Predicting where something's going to be in the sky is not measuring an orbit.
Yes, it is.
They don't even know if that thing moved. They don't even know if that thing moved or not.
How do you predict it without measuring?
Yo, they don't even know if that thing. They don't even know if that thing moved or not.
Okay, you've said that 10 times already. Answer the question.
So that's obviously not measuring an orbit.
How do we know? How do we know when
What is a
how do we
fucking
know when
measurement?
eclipses? Yeah, how do we
What
know
is a
when
measurement?
what are you saying there, new guy?
What is a measurement?
That's a new guy. He's new.
Okay.
I'm new to this topic. I'm just asking what a measurement is. Do you know?
It's
Let me ask you this: is it a calculation? Is a
it's
calculation equal
calculating
to a
things.
measurement? Let me
Is
ask you
what?
that: is a
what?
calculation equal to a measurement?
It can be.
Oh, it's so
Like you can
Judges?
measure something with a yardstick, and then you can use math to measure things on larger scales.
so much.
So all of those
doublespeak.
patterns that you recognize in the sky, you're just going to make up a so-so story about gravity, which can't be put through the scientific method, and say it's because of that?
No, that's gravity is scientifically proven.
What are the components of a scientific hypothesis?
He already fucked this up like an hour ago. He has no clue
Oh,
what the method is.
Nobody in here can make a hypothesis.
does he know what an
before
independent
Pendulum.
variable is yet?
Yeah, he doubles down and says,
Nobody
nope, it's still
knows.
science,
Nobody-
even if it's just an observation. And even if it's a correlation, I'm still going to claim causation. That's where we got with the Foucault pendulum. He thinks that's science. So you're not getting anywhere with this guy in that realm.
The only answer I've ever gotten out of what went bang was the singularity.
Yeah, the whole Big Bang theory. There's just too much we don't know. That really can't be proven.
So he understands that gravity can't be an independent variable, and he doubles down and he's just sitting here preaching his delusions.
Yep.
It's not a delusion.
Back away from the Big Bang
Yeah,
theory, though.
you're making up definitions and you're believing in things that aren't real.
No, I'm not. I'm just saying
gravity is an independent variable that someone can manipulate.
We can measure the expansion of the universe.
We can measure with a tape measure. We can
measure what by observing with math, triangulation, all of that.
Is it math? What kind of ruler is that? Is that a device you're talking about? Physical thing?
You don't need that to be able to measure.
So you'd be calculating them, wouldn't you? Yeah, not measuring.
What?
You're using the wrong word. You should use the right word. I'm just new here.
You can measure using math, using science. You know how triangulation works, right?
Do you know how measurement works?
Of course.
Is that like a calculation, or is there a reason
you
we have
can
rulers?
do all kind. There's various ways.
So you're saying they're the same thing? Okay.
Sometimes not.
In what way are they sometimes the same exact thing?
Depending on what you're doing.
What is the depend? How am I going to get a measurement by calculating it? How is somebody going to say like, oh, you did a good measurement there by calculating it?
Let's say you take a yardstick and you want to measure your room. You can go bit by bit by bit by bit by just.
Are you going to use an actual yardstick then for this? Let's make it where you don't do that.
What I'm doing is using an example. I'm using an anecdotal example here. Okay, just bear with me.
No. Use a real example because I'm actually asking you what a fucking measurement is and what a calculation is, and if you know the difference. That's
what I'm doing. That's what I'm doing. Just let me go through this whole thing.
You can make yours. I'll lay out for a bit. Nice talking to you.
All right. So you take a yardstick. You just go bit, make a mark, do the next bit, and then just go on. Or you can just take it, make one mark, go back, take a photo, and then take a photo of it with your phone, and then you can do a little math and calculate exactly how far it'll be. And if you go back and do it the long way, you can see that your result can be verified.
So if I assume a bunch of stuff and I calculate the length of Superman's shoelace, did I just measure it?
Yes, you can. Yes, you can, in fact, do it. That is if Superman had shoelaces.
Oh, I can measure Superman's shoelace. Excellent.
You see this guy in here, over here with the hockey mask guy. You know, I don't know what he weighs, but if you tell me what he weighs and just based on human proportion, I should be able to get a rough outline of his body, right? Like all that stuff, right? Did I measure him? Did I measure his proportions? I'm gonna make a suit, right? He's just gonna tell me how much he weighs, you know, and his height, right? Do you think I can infer all that data? Do you think I'm gonna get it right?
To a degree, you can. Like you need enough information. You kind of can. Like, let's say you have someone's weight and their height. You can calculate it, and you'd probably get, it wouldn't be exact, but you would get really, really close just from that. If you're making a suit,
probably gave you too much.
Close enough for government work. I mean, if you wouldn't do that if you were a tailor, but still.
It's different than measuring, though, right? Would I get a more accurate thing if I was measuring it, or if I was just calculating it based on some some data points, right? Isn't that that's essentially, I think, the difference we're talking about here with calculating orbits or measuring them. And you want to use the word measure, and I'm just saying that's probably not a good way to do it. But you could, if you want to think of it that way, that's fine. I don't care. I just mean semantically, I don't think it's a good. It's good. It's not a good way to say it. But I probably talk too much in here. Somebody else probably get you.
Let me try to explain it like this. Let's say you want to get a man a suit. You have them put their phone on their chest, like, attach it to them. You hold it right to their right to their shoulder or something.
So you're going to give me a strategy for measurement. Okay. But then you're actually using a real thing.
Let me finish that. Let me finish this illustration, okay? So then you can have them tell you exactly what the make model of the phone is. You can go online and figure out the exact dimension of the phone. You see?
You're just giving me another
dimensions,
reference.
the width,
When did you measure a planet, though? Like, I'm just saying.
Okay,
let me finish.
Let me finish, please.
You grant yourself all these exact. Right? You're saying I can get the exact dimensions. Yeah, through measurements. That's the point. You got your dimensions through the measurements.
Yeah. So you do something small scale. You do something small scale, and then you can apply it to large scale. That's how it works. That's how this.
Yeah, with measurements.
That's how it works.
You even in your analogy, you used measurements to generate something, right? Even in your analogy, you went right to measurements. I have the dimensions. I have measurements that were taken. And then you try and argue against needing those measurements in the first place.
No, I'm not. I'm saying that's exactly that's what you need. That's what you use. You have the baseline. You can use that.
No, everything's
that's how science works.
Everything's an approximation. Sorry, buddy. You have no dimensions. Everything's just an approximation.
And the thing you've never been able to debunk, is exactly how we can detect all of these things. We can predict all of it without measuring.
No, you can't. You're not predicting it. It's on a cycle. It's systematic. It's habitual observations. It keeps happening. So we see it over and over and over again. You're like, oh, I predicted that. Well, didn't that happen?
Is that called pattern recognition?
Pattern recognition to predict exactly when the moon's gonna, when I'm gonna be able to see an eclipse down to the minute.
You studied a cycle for thousands of years and wrote it down for about, I don't know, at least 800 years or something like that. Is that pattern recognition? If you're like, oh well, the same thing happens every 7 years, every 21 years, every this many years, right?
Because it's not really predictable.
You don't. Right. Serious?
You can't. You really can't. You can't predict it like that.
Then how you predicting it? You just said it's not predictable.
You're not listening to me. We measure the orbits, the moments, all of it.
Tell me how you calculate the Metonic cycle.
We can't do it otherwise.
Tell me how you calculate the Soros cycle. Yeah.
All right, I'm going to continue with what I was saying. My mom saw a solar eclipse in the 70s. I had to wait until 2017 to see it, and then I got to see it again in 2024. So the pattern is random. There's no way for us to have predicted it without measuring the exact movements of exactly when the moon will do this, modeling all of it.
So you don't think the orbits are systematic? You don't think all the orbits are on like a system, like a cycle?
Yeah, the patterns
They
in the
are.
sky are not random.
Okay, so why are you claiming they're random then?
I'm not claiming they're random. I'm saying we can predict them. We can measure them.
You said I saw eclipse 3 different times, and that eclipse was
No,
random.
I didn't say it. I said I saw it twice. My mom saw it.
Do you think all the planetary bodies are on a cycle? And you're like, yeah. Okay, so how's it random?
I'm saying the randomness is in how the timing of them, like once in the 70s, once in the 2010s,
right? So it's not on a cycle.
Once in
random?
in this decade.
Okay, so it's not on a cycle. It's random. That's what you're saying. The timing of them is random.
The timing of it for us, for where I live, does appear to be random, but it's the movements of them all are systematic and are predictable down to the square mile.
So
that's why I always knew beforehand.
Understand them. You just trying to work the word random in there, even though you know it's not applicable.
I'm saying it appears to be random from my perspective, when in reality it isn't. That's what I was saying.
So it appears to be something that you know better than. You know
it
it's not random.
It appears to be, but it really isn't.
Okay, so why does it appear to be random when you already know it's on a cycle? Why would you ever think it's random?
Because standing on Earth, that's what I'd think. That's not a valid, answerable question.
Yeah, I know. It's called incoherent. Your statements are completely incoherent. You're trying to make an argument that it's random while you're claiming you're making a positive claim.
I'm not trying to say it's random. I'm saying it appears to be.
To you,
you're not listening
to nobody else. Nobody else observing this thinks it's random. Just you. For some reason, even though you know better, you still think it's random.
Appears to be. That's what. Repeat after me. Appears to be random when in reality it isn't.
No.
Repeat those words after me.
You just think
appears
it doesn't.
To be.
It appears to be on a cycle to everybody else except for you. You're on an island.
Okay, you're straw manning. You're straw manning my arguments now.
No, I'm not. Not at all.
Yes, you are.
You said it appears
I'm saying one thing, and you're saying something else entirely.
You say it appears to be random, right? But it's not random. It's on a cycle. I say everybody sees that cycle. We deciphered that it's a cycle. We've come to this conclusion, but for some reason, to you, it appears random. But everybody else, it appears
you're still strong. No, that's still a straw man, because overall, it is a cycle. It's something that we can predict exactly when it happens, because we can measure.
You're not measuring. You're going back to that.
Yes, we are.
Thing.
Yeah, that's another straw man.
How about this? Does it appear, right? Does it appear to be on a cycle, or does it appear to be random?
For me, on the ground, without knowing much of anything about anything, you would assume that it just happens every now and then.
You
wouldn't. There really isn't a pattern to it at all. What you'd think. That's what you'd think. Just sitting here on the ground, not thinking about, not knowing about the movements of the stars.
Everybody else thought. Yeah, not everybody.
No, that isn't what I'm saying. That is not what I'm saying.
Right? In history, they wrote this shit down. They logged it. They logged the fucking heavens. They were taking notes. They're saying, "Oh shit, this shit's on a fucking cycle." But for you on your little island there, you're like, "Oh, all this shit just appears random." Well, nobody else thinks so.
That's not what I said.
You said Big Daddy Science came in and solved it.
Yeah, well, everybody else is studying the pattern. You're just claiming it's random. It appears random.
You're still straw man. You're still straw manning me.
It appears like it's
I said it appears. It would appear if I am just sitting here and don't know anything about what's going on. It would appear to be that.
To be on a cycle. Yeah, so if you're not paying attention to anything anywhere at any time, and you never look at the sky and you're like, oh shit, there's an eclipse. Oh, that's random. Yeah, sure, if you're not paying attention, but to everybody else that's paying attention, it doesn't appear random. But you want to die on this hill for some reason.
Because you're not really making sense, and you keep twisting what I'm trying to tell you. trying to
I'm
distort
putting
it
the
for no reason at
consequence
all.
of what you're saying back on you and
No,
making
you're
you hold
not.
true to both statements. You're saying it appears to be random. Is that true? Yes, no. Yes. Okay. Does it appear to be on a cycle? Yes, no. Which one's true? They can't both be true.
Reality is that it is predictable. It's it is a cycle. That's how we can math it out exactly when it appears and stuff. That's what I've been saying the entire time.
Okay, so it doesn't appear random.
But
glad we got past that.
No, stop. If you're unaware of the maths that are involved, you would think that there's not much of a pattern to it just by standing on the ground. Reality is it isn't
when they charted
but
it.
you assume that it is if you don't know anything about what's happening in the sky.
Yeah, they weren't using math of the orbits when they charted all this. They were doing
Yes, they
observations.
were.
No, it was observations.
Yes, they
I guess you
were.
could say angle measurements. Yeah, sure.
How long?
But they were doing observations, repeated observations, and saying, "Holy shit, we see a pattern here. It's got to be on a cycle." And then what? Thousands of years later, you come along. This shit's just random, bro.
That's not what I said. You're straw manning me.
I don't think you know what a straw man is.
No, I'm saying you're mischaracterizing my argument.
You're trying to weasel out your own argument.
All right, we're still here.
So no measurements and not random. Cool.
Yeah, we do have measure. We can measure it. We can predict exactly when
You're not
the next
predicting.
eclipse
It's
is
on a
going to
cycle.
happen.
It's on a cycle, right? And that
But
cycle
that's why
was
we can
figured out.
measure exactly we can measure the exact trajectory of totality years before it happens.
You're missing it again. You're missing it again. You already said it's on a cycle. Okay, did we figure that out, or was it already figured out? Was there a systematic effect of the heavenly bodies that we were like, oh shit, yeah, this shit's on a cycle, like before us? Was that figured out?
Yeah, but that doesn't explain how we know we can predict it down to the square mile.
The totality.
That's what I've been trying to get you to. That's what I've been trying to get you to say is that we can.
We don't have a totality of orbits. We don't have that.
Okay, totality as in the moon fully covers the sun, and that you can take off your eclipse glasses if you're in a certain range. You're outside that range, you're going to need eclipse glasses on the whole time, or else you're going to have problems.
So not a totality of orbits, because that's what we're talking about. The celestial bodies.
That is not what I'm discussing right here. I'm not talking about that. I'm talking about.
That's what we've been talking about.
I just described totality to you.
Yeah, you just changed it. We're talking about orbits now. You're like, oh, I'm going to talk about the totality of an eclipse. Like, okay.
Of course, because we can predict where and when it will happen.
Yeah, through repeated observations. That's what I've been saying. And you're like, no, the only reason we know that is because we measured something.
Math.
No, that you forgot to measure.
No, through math.
No, it was figured out for us.
Figured out for us thousands of years ago. No, that's not true.
Well, not thousands, but it was figured out before we were born.
I'll take your. Could be true, could not be true. I'm not going to look into it. Exactly when it was figured out when the eclipses are all going to happen.
There's a lot of civilizations that have a lot of data of the bodies, the heavenly bodies, spinning around, floating around, whatever they're doing up there.
Yeah, but they can't make accurate predictions like that.
Then it's not on a cycle, and they didn't figure out a cycle.
No, because they don't have the equipment and data to measure when and where it will happen.
So how'd they do it?
I don't know. I just know they do.
Observation.
I just know they do it. I just know they do it.
Habitual observation. They're like,
no,
oh shit,
that isn't how it's done. Cool. That's not how it's done. You keep
That was done. Literally how it was done. Yeah,
no,
comparing data from over the years. And then equating all of it and calculating everything and be like, oh, this must be what it's doing in total. I mean, it could just be random. I don't know.
Can we use random to measure things? No.
Nothing in the sky.
Use a random number generator.
What's up, Rob?
I was just saying, nothing in the sky is random. I'll even put that to like airplanes and shit. Unless you're just a joyriding pilot that has no destination. But I don't think you're allowed to do that as a pilot. Just fly willy-nilly. I think you have to have a flight plan. So nothing in the sky is random. Thank you.
And that's what I was saying. That's what I was saying first. Is that with general relativity, everything's predicted, everything's ordered, everything makes sense.
Then
all right, I found a source. I'm going to put it in the. Hang on. I'm going to put it in the. Let's see. In live stream text. I'm going to put it right in there. All right, right there, it explains how solar eclipses are predicted. Using advanced astronomy, including factors that'll pinpoint when and where they'll occur.
Based on what?
It's based on some knowledge of celestial mechanics, how the planets, moons, and other heavenly bodies move through space. Solar eclipses due to the precise alignment. They don't happen every month because the astronomers use mathematical models that account for orbits of Earth and Moon, their inclinations, their elliptical paths to predict precisely when these alignments will occur. To understand the different phenomenon, here's a guide on solar eclipses.
Based on what data? From habitual observations.
Solar cycle period of approximately 18 years. After one, they're going to be close to the same positions, making it possible to predict. This ancient method remains essential. Orbital dynamics. Astronomers use highly detailed models of the Earth's orbit around the Earth and Earth's orbit around the Sun. These models consider factors like the moon's tilt and orbit's elliptical. Yes, they do. It's what it's what the source says they use. You're saying they don't work? You're an absolute moron.
It's called the end body problem.
If you say if you're saying that what the astronomers literally do does not work, you are an absolute moron.
Yes, are you familiar with the end body problem? Because you said all the model works. Okay, the model is a bunch of balls spinning around each other. Okay, where's that model? You're gonna look for it, and you're gonna be like, "Oh shit, I got a 3-body problem." Then you're gonna look further. You're gonna be like, "Oh fuck, it's actually an n-body problem." Now what the fuck do I do with this? Shit, this doesn't work. I gotta throw Newton completely out the window now.
Okay,
Newton
that is beyond the scope of this conversation.
Now I gotta go to relativity. That is beyond the scope of
this conversation.
Yeah,
just like you and your whole
you claimed
nothing is moving crap.
You said I have a model of all
you're
the balls up there.
now. I'm trying to explain it, and you're losing. So now you're resorting to strawmans as you always do.
You claimed the model of all the balls up there, right? You said we have a
highly detailed models. I'm going to guess it's all CGI.
You have a predictive model, okay? In that predictive model, you also have an end body problem that has not been solved. that will never be
Okay, and
solved.
that is irrelevant to this discussion of how they're predicted, how they are predicted.
Wrong.
That is
Completely
irrelevant
wrong.
to this conversation.
It's
For a
not
solar
relevant.
eclipse, astronomers can use
It's the
shut up
crux
and listen.
of your model. You say, I have a model, and I'm pointing out where your model's broken, and you're like, that's irrelevant.
Okay. Yes, because we're discussing eclipses, and you're trying to bring in something that's out
We're
of
talking
focus.
about the planetary bodies, dude. That's what we're talking about. The planetary
No, we're talking about eclipses and how they work.
Hey, then you need
You're
three
trying
bodies.
to talk about something. You're trying to talk about a bigger problem that has
then you
nothing to
have
do with
three
this.
bodies, and then you got the 3-body problem.
Okay, we're talking about
Sun,
the 3
moon,
bodies.
Earth,
Then
3
we're talking
bodies.
about 3, and that is it. Shut up.
Okay, then you
we're
have a
talking about
3-body
and
problem.
that is it.
Okay, you have a 3-body problem. What don't you get?
What do you not get? You don't get a lot because you're not letting me read. This requires precise calculations of the Earth's rotation, the moon's distance from Earth, and the speed. Okay, yes, you do because you don't understand what you're talking about.
Yeah, you need to go read about the 3-body problem and
Okay,
then get back.
We're not talking about that. We're talking about this. How many times do I have to say it?
Are we talking about the orientation of 3 bodies in space?
For this very brief segment that I'm reading, I guess.
Now you have 3 bodies in space.
But that is not what we're discussing here.
I have a model, and I'm saying in your model you have a 3-body problem.
But we're not discussing the 3-body problem right here, right now. We're discussing eclipses.
I'm telling you, it's the crux of your model. You said you have a model.
Which is irrelevant. How modern technology enhances predictions with the help of computers and advanced astronomical software. Predictions are made far more precise than those made in ancient times. Astronomers use satellite data, space observatories, and sophisticated algorithms to refine eclipse predictions. These tools allow them to calculate the timing down to the second and pinpoint the exact locations that fall in the shadow.
Did you give up on knowing things now?
Okay, what are you saying?
Did you give up on knowing things and you need to read them now?
Yeah, because, he's not shutting up long enough for me to read and explain things.
You can't explain it.
Jeremy made that same complaint while he was trying to explain things to you and you were cutting him off. Is that pot calling the kettle, whatever? I don't know what that phrase is. You know what I'm saying,
calling the pot calling the kettle black?
It's not a racist statement. It just means that, you're doing the thing that you're accusing him of.
The pot is a white supremacist in that analogy.
Yeah. Okay. Yeah. So that's just another.
You know how I know that? Because my model predicted that pot would be a white supremacist. Okay.
And
it predicted the kettle would be black.
You're talking about race now.
Yeah. Well, in my model,
I'm just trying to explain
literally anything to dodge.
It's just an idiom.
My point here.
You don't have a point.
Anything to dodge my point.
That's the irony. Okay, ready? Here's your point. I have a model. It has predictive capabilities. Therefore, I can predict when the eclipses come. I say you have a broken model. Here's the broken piece in your model. And you're like, that broken piece doesn't matter. My model is still accurate. It's not broken. Okay, we'll just say no.
I'm saying
that's
for the
fine.
sake of the no.
But you got no fucking
no. That's
argument.
a straw man. That is a straw man. That's a straw man. For the sake of this discussion, that is irrelevant.
It's not because you have 3 bodies in space.
I am not denying that. I'm not denying that exists. But what I'm saying is I'm trying to explain how eclipses are calculated, and you're trying to talk about something else that has nothing to do with it.
I'm trying to talk about the model. You're saying I have a predictive model. Okay, well, it's broken.
Okay, you've said that 5 times now, and that doesn't change what I'm trying to explain to tell you.
Pointing out that it doesn't predict because it's fucking broken.
Rhaegar,
and you're like, no, it still predicts. No, the math predicts it. The math is like, oh yeah, I can make the math kind of sort of work, and we get an estimate approximation. Yeah, that's cool. But go ahead, you can't model it. Second you go to model it, the shit falls apart.
Yes, we.
Yeah, and Newton goes out the fucking window. That goes right in the dumpster.
Rhaegar, have you mentioned dark matter or Einstein yet? If not, you're not trying hard enough, man. Was Newton a Freemason?
I can't even get him to accept a 3-body problem, let alone go anywhere else.
Because it's not relevant to this conversation. It's like, if I started to bring Einstein if I started bringing Yeah, it's roughly the equivalent of me talking about Newton and you trying to say, no, we can't trust him. He's a Freemason. It's completely irrelevant.
That's completely.
egregious.
Why'd you have to throw him that bone, Red Cloud? That is such a fucking irrelevant nonsense
that's what you
point
do,
that
Red
you brought up.
Yo, but
that's what you do all the time. That's what you've always done. This whole conversation.
You're giving him an out, Red Cloud.
When we start getting close to the mark,
you shouldn't be able to talk anymore.
Santa,
there is no mark. That's the
yes,
problem.
There is a model.
No, there's no mark. There's
the
no
model
model that works. You just got a bunch of claims that there's a model.
May I just say, like, it's
scientists claim there's a model.
No, they don't. They
do.
Yo, shut the fuck up, yo. Let Snax go, dude.
I'm just saying, like, it's based on the idea that we earlier established that we can't talk about Einstein because it's above like his or anybody, I guess, whatever. You know, we're appealing to like that's too high of a standard. So we have to stay with the Newtonian, right, to have a conversation, right?
Yep.
So that's the real reason why we can't go into Einsteinian stuff. Red Cloud, not your stupid straw man.
Yeah, no. That's usually when you get close to the mark.
Yeah, usually you can pay attention to actual conversation. I know you want to make generalizations.
Yeah, the mock is like stay on Newton because I don't want to talk about relativity. Okay, well, let's talk about Newton and let's talk about the consequences of your model when you apply Newton to it and your whole fucking model breaks. Oh, but that don't count. That don't count. I still need Newton.
Yeah, of course, because we're talking about eclipses, and I'm trying to be very straightforward and explain exactly how we predict it, and then you're trying to throw curveballs in to ruin everything.
No,
trying
I'm
to
telling
monkey wrench this whole thing.
I'm telling you,
and it has nothing to do with it.
A model, the model has to work.
I'm saying you're trying to monkey wrench. You're trying to monkey wrench this entire discussion, and it's annoying.
It's not my fault. Your model doesn't work. That's not a monkey wrench.
Monkey wrenching and straw manning. Shut up.
That's not thrown from my hand. That's the mainstream dropping that wrench.
Straw man.
What we can do is using our model, we can predict the path of totality. Which, even though you can predict something like just when the eclipse will occur, is one thing. But when
what do you mean by model then?
When you
your calculations, is that what you mean by model calculations?
When you can predict ahead of time where something like the path of totality is going to be on a moon eclipse, where it's actually going to be years in advance, that not just the moon appearing or whatever, then you know that the model has some validity.
Okay, and what is this model? A calculated model? Is it a model based on calculations?
It's
based on observations.
It's the solar system.
Habitual observations, right, of the past,
and measurements of the
compiled into
the motions
a calculation, because it's not simulated with anything physical.
No, straw man.
No two paths of totality are the same. Not one has ever been the same. They're different. They're not predictable. So that claim that it's just repeating is false.
Thank you.
Try harder.
Wait, so you're telling me the heavenly bodies are on a cycle?
I'm saying that the path of totality on any eclipse is going to be different and is not predictable. We have a model, so we can predict it years in advance. And we can say, right, next year, I'm going to go to Houston, Texas, because the path of totality is going to be there. And lo and behold, what happens next year? The path of totality goes through.
So not predictable. Not predictable,
time.
But now it's predictable.
It is predictable. It literally is predictable. Like,
yes,
so dishonest the way you paraphrase. So dishonest how you paraphrase it back completely wrong, as if they said something completely different.
He says it's not predictable, and then he talks about how it is predictable. When I'm saying it's on a cycle.
He never said it's not predictable.
It's just
yes, he did.
It's two angles. It's not that crazy, dude.
Exactly.
This isn't that crazy.
It only goes two ways, man. Like, how much are you predicting? Like, it goes this way or this way. Path of totality. I know it sounds really cool to talk about.
Because we have a model and we can predict it. And the other reason we know is because it's not repeating.
You don't know what you're talking about, do you?
I do.
Well, when I ask what the model is, what is it?
In here, look it up.
What's the model, Red Cloud?
Totality is identical to any other that's ever recorded in recorded history.
Okay, what's the model that predicts it?
The globe model.
The globe, the solar system, the heliocentric model. That's what it's called.
That people had left for hundreds of years in these paths of totality. Yeah. Yeah.
Yeah, because they can see them. But there's never been.
Yeah. When they were carving it in stone in the Southwest, you know what I'm saying?
So if we would agree,
isn't that cool?
Ours was
Isn't that cool? Just like you don't need science, right? You just have like a fucking another rock, and you're like, I'm gonna notate this on a rock, and it's still there right now in the forest.
Yeah, you're on a rock.
In the petroglyph forest, which is in the path of totality, dipshit.
You're on a rock. Yes, you are.
So you don't understand what you're talking about, do you?
Yes, because there's no two paths of totality have ever been recorded to be identical. Prove me wrong. If there are globers in here, prove me wrong.
You're just objectively
correct.
No,
prove me wrong.
The diametric opposite of correct is what you are.
Prove it, or just talk some more BS. You can do that.
I've been talking
I'll do both.
Wait, what do you mean by that? What do you mean by that? To what precision?
More precision
relative.
than any model, because there isn't another model.
Well, support your claim then. You made a positive claim, didn't you?
You got the Soros cycle and the Metatonic cycle. They do repeat after so many years, but you don't get the same eclipse until the whole cycle repeats. It might take hundreds of years. A whole lifetime.
Tell me if there's a path of totality that's ever been recorded to be identical from another. That's all I'm saying.
I would say yes, because the cycle repeats. Yes. It's a cyclical cycle. It repeats after.
It's only two ways.
300 and something years or whatever.
Have a guess. Just have a guess. Yep, I reckon it does. Yep, I'm going to go with yes. I'm going to take yes for 200, Larry.
With no substantial
cycle. If it's on a cycle, there has to be something that repeats. Like everything will eventually repeat if it's on a cycle. Otherwise, it's not on a cycle.
You don't understand what it means then. Okay,
that's not a rebuttal.
All right. Well, actually, no. Let's talk about not understanding, right? Like, is there a constant speed to the sun and the Earth? Right? Do these things change speeds? Because if they're the same speed all the time, there's going to be a cycle. It's just a fact. It's just fucking logic, Red Cloud. You should just
get used to it. You're on a ball.
I'm trying not to insult you. It's hard. It's very difficult for me. I'm really pulling back.
Everything. But what are you trying to say? There is a pattern? Then prove it.
If there is a
we
pattern,
have proved it.
Well, I don't see why I'm holding back insults.
You're just ignorant. You're just
this is chaos.
spouting shit.
He's like, prove orbits. Prove orbits. Okay.
We have ephemeral cycles, dumbass. We have not only do we have equinoxes, and solstices, we have the eclipses also, dude. Going back to 2000 years BC.
Paths of totality. Stay on topic. Show me where there are two paths of totality identical.
Well, dude, if you're listening, listen, bro. If the whole cycle repeats, including the position of the luminaries, the eclipses are also going to repeat. They just don't repeat exactly the same way every single year or every 10 years, every 18 years.
Exactly right.
You need a model to make accurate predictions.
If you can't see the cycle,
well, dude, to what precision? To what precision? Because according to Jared Hickson from King's Dethrone, which I have a quote from him, the Chaldeans used to predict the eclipses 3,000 years ago with a degree of accuracy that is only surpassed by seconds in these days because we have wonderful clocks, which they did not. Yet, they had an entirely different theory of the universe than we have. The fact is that eclipses occur with a certain exact regularity every so many years, days and minutes, so that anyone who has the records of the eclipses of thousands of years can predict them as well as the best astronomers without any knowledge of their cause. Or
really try to read
specific
that book,
shape of the earth. Was it?
No,
is in a condition?
Gerard Hickson's,
all you need is habitual observations.
It's a very good
book.
So Zion, what does that guy say about path of totality? Can you quote that?
Okay, but hold on. You keep talking about the path of totality. I understand that the path of totality is the most difficult one to predict out of all of them. You guys claim with no evidence.
Which our model does.
Lack of evidence isn't evidence of your claim, right? That they didn't have the ability to predict totalities. You don't know that.
We do know that because there are no.
How do you know that?
Totalities up until the 20th century. Any glober in here, find that I'm wrong. Tell me that I'm wrong.
No, hold on. No. Hold on. How do you know? How do you know that the Greeks or the Chaldeans did not have the ability to predict eclipses, or to add to that, total eclipses. How do you know that?
Because they didn't record it.
How do you know that?
Prove me wrong.
What the?
Dude, the burden of proof is on you. When we have records that they didn't predict eclipses. You're saying that they didn't predict totalities. How do you know that?
Some actual research, just for once.
I have, dude. I have, and the ancients were incredible astronomers. They knew how to predict exact conjunctions within hundreds of years. They knew exactly. The Mayans, the Chaldeans, the Babylonians, the Hebrews. You're telling me that they were idiots, that they didn't have the capabilities or the capacity, and I'm asking you, how do you know that? And you're saying, well, we don't, because we don't have any records. So again, so lack of evidence. Hold on. Lack of evidence isn't evidence of his claim, dude.
But you're saying go with the evidence that you have. You can only use evidence that you have. If you don't have evidence for it, you can't use it. You can't say that, they didn't record it. We found no recordings of the path of totality, but they still could have done it, so I win. You can't say that. We
the fact is we do have evidence. Hold on. We do have evidence. We do have evidence that they were not only capable, they had the capacity.
We know this already.
To predict eclipses, right? You guys are saying that because we don't have the exact records of them keeping totality, therefore they weren't able to keep totality. Where's so lack of evidence isn't evidence.
Yes, lack of
evidence. But the burden of proof,
that's known as an appeal. It's an appeal to ignorance.
You love fallacies. The burden of proof is if you claim that they had ideas of passive totality, is to show the evidence of it. You arguing with Red Cloud is shifting the burden of proof to him, that to disprove that they didn't have the passive totality. So you have to show your evidence.
The point is that model is required for that level of accuracy. And with no model, there's no way you can predict something as accurate as the path of totality of the moon. I don't even think they even
calculations are required.
Was because they didn't have.
Doesn't work, dude.
They didn't have the ability to predict it because they didn't have that level of communication for starters. So there's no way they could have even known there was a path of totality to begin with. Doubt if you'll find that term.
So you make that's the thing. You're making these positive claims, right? You're completely disregarding the Chaldeans' capacity, right? With no evidence. That's the difference.
So, Ryan, are there any evidence of the Chaldeans proving eclipses in other locations?
Yes.
In all locations?
No, see, that's what I'm saying. The fact that just because we don't have the records in all locations, right, to the second, doesn't mean that they weren't able. That's the problem you guys are making.
That's the argument.
The Chaldeans,
you're straying far away from the argument.
I just want to say that the Chaldeans were not aware of North America. The Chaldeans were not aware of Antarctica. But we're supposed to go, the Chaldeans knew stuff. They didn't even know Antarctica existed.
That's logically irrelevant. That's a red herring. I already brought up Jared Hickson. We have cuneiform. Hold on, dude. Shut the fuck up. I'm talking. We have cuneiform tablets. Dude, shut the fuck up. We have cuneiform tablets with. Yo, are you gonna keep doing this, dude? Are you threatened by my speech that you don't allow me to? You're just gonna fundy mute me, dude, and talk right through me? Stop. Cuneiform tablets with recorded eclipses. Archaeologists have discovered thousands of clay tablets from Babylonia written in cuneiform. One of the most important collections is the Enuma, Anu, and Lil. These tablets record actual eclipses, solar and lunar. No dates, times, and appearances.
We know this.
Dude, shut the fuck up, dude. Now I'm bringing the evidence and you want to fundy mute me, dude. Shut the fuck up.
Not evidence of the
sorrow cycles explicitly appears in their data. Later Babylonian tablets show awareness of eclipse repetition cycles. That's what we're trying to explain to you guys. All you need is habitual observations, so then you can record the geometry of the ephemeris. And guess what? It's not exclusive to a globe. All you do is record these ellipses on a fucking tablet, and guess what? You have the conjunctions, and you can predict through the angle where the eclipse is going to happen on the Earth. It doesn't take a fucking rocket scientist with relativity to figure this shit out, retard.
My previous statement stands.
You got these tablets with these cuneiforms written on it, but there's no mention of the path of totality on that tablet. You're saying it could have been on another tablet. There's a bit of space at the bottom of the tablet that everything's written on, but they didn't put the path of totality on it. But it could be somewhere else.
I don't have to provide that. The only thing I have to provide is evidence that they had the capacity to predict eclipses. If totality is missing, lack of evidence, missing evidence isn't evidence of the contrary. You can't make a positive claim with lack of evidence. You can't say that they were not able to predict totality because you haven't found the evidence.
So dishonest.
That's known as an argument. Hold on, bro. That's known as an argument from ignorance. Lack of evidence isn't evidence of a positive claim, and you guys keep making positive claims saying that. No. You guys are saying they weren't able. They weren't able. They weren't able.
They don't have that evidence. You're ignoring that. That's it. You're ignoring the fact that they don't have what you're specifying. That's what you're arguing.
Well, what do we have then? All right, what do we have? We say, okay, back like fucking over 2,000 years ago, they could predict eclipses were on a cycle, right? So for like what, 1,500 years, they were nobody. For them 1,500 years, there was a serious fucking low where nobody could figure out totality. That's what we're putting forth.
Yeah,
that's our theory. Our overall theory for 1,500 years, they couldn't figure out the path of totality, even though they had cycles, repeating cycles.
How many times? Knowledge can expand by learning.
That's a serious low.
What's a low? That people 1,500 years ago didn't have the same technology that we had, or the same computations that we had? Dude, you don't even know what's going on in academia right now.
I'm trying to answer your question. For over 1,500. Yeah, you said, well, what's the low? I'm trying to answer it. The low would be for 50.
I didn't say that. I was still trying to finish.
That's what I heard. That's what I heard. So I'm going to go ahead
and answer well, you were wrong.
I say for 1,500 years, there was a huge low of no advancement while everybody's up there looking at the sky.
Do you know what's going on in academia right now?
Riga, do you know what's involved? Do you know what's involved, Riga? In
how many questions you guys? You guys want to go 2 at a time, 1 at a time, 4 at a time?
Yeah.
How do you want to do this?
Have you ever tried to calculate the path of totality? Do you know what's involved?
Yes. I'd say moon gazing, sun gazing.
Right. So you've never actually approached even trying to consider doing a calculation that would calculate the path of totality for, say, the next one. You have no idea what's involved. It's extraordinarily complex.
Well,
it's really complex.
You need a map. That's it. The map is what they were lacking.
Just fallacy on top of fallacy, bro. Now he's attacking. His intelligence.
I'm not attacking his intelligence.
You're attacking. You're attacking his intelligence.
You were the one who's saying shut up before.
Yo, hold on.
Everyone was.
Originally, you guys were talking. Hold on, bro. You were no, because I was talking, and then you got triggered and started talking over me, bro. Chill out, dude.
You interrupted.
So originally, you were committing an argument.
So stop talking, and I'll finish.
An argument from ignorance.
Okay.
Oh my God!
You already finished, Ron.
Yo, they want to talk over me every time.
Oh, right.
Again, absence of evidence is not evidence of absence. Again, absence of evidence is not evidence of absence. And now you're doing borderline intellectual snobbery. Yeah, because
let him finish.
Dude, he finished.
He did finish. I'm trying to actually get something out. You guys just keep talking over me because you're triggered.
Shut the
finish
fuck up.
He finished, dude. He finished.
Stop spurging.
You chill, Doza.
I'm not spurging, dude. I'm trying to get my words out. If you guys just let me talk, I wouldn't be
I'll talk when you're finished.
Again, absence of evidence is not evidence of absence. That's a fallacy. You guys are claiming that they weren't able to predict totalities because we don't have any extant cuneiform tablets or any fragments of scrolls that survived 3,000 years. And now, because of that, you guys are making positive claims. What you're better off doing is being agnostic and be like, well, I don't know if they were able to or not, but we do have evidence actually that they were able to, even though it doesn't say with specificity regarding the totality. That's it, dude, because we do have plenty of evidence that they were able to predict solar and lunar eclipses.
I agree with that in the sky, but this my conflict with what you're saying, Vine, is that the path of totality is that it's inferred within it that it's a ground position. That would be the path, and you would need the map to predict the path of totality.
Yeah, and back then they believed in a planar cosmology. We have records of that, and that's what I'm trying to say. It's not exclusive to a globe. They were able to predict eclipses, lunar and solar eclipses, over a flat surface. All they needed was geometry.
They literally had half the Earth, not even that. And you're using that as proof of them being able to do everything that we're doing now?
Correct. All you need is basically, if you have, all you need is multiple astrolabes, right? You can, like, you know what an astrolabe is? That's all you need.
Explain it to me.
It has the eclipses, the epicycles, the lunar phases, their positions in the sky relative to each other, to the wandering stars and the sun. And it's all it is habitual observations, and you have these gears that come together, and there's conjunctions periodically, cyclically, and they can literally predict their orientations in the sky, and then where they are, where they live, whatever latitude that they live in relative to those positions. They could predict eclipses. It's very easy.
Okay, if I could draw a parallel to what I think you're saying and maybe explain it. It explained it to me when I thought about it in my head. We've got a stab victim, right? But we've got no weapon. We can't find the knife. Okay. What you're saying is, what I think you're saying is that we are claiming, no, it couldn't have been a knife, right? Because we can't find the knife. And you're saying, but it could be because we've got a stab wound. Okay. What I'm saying is, you don't even have a stab wound.
I don't even get that, dude. Was that?
It's not even.
Do you get it, Ryan?
Because that stab wound would have to represent the fucking total eclipse. And you're saying that doesn't.
So you've got a stab wound. So it's fair to say that a knife caused it. Okay, but you guys don't even have a stab wound, so you cannot say that it was a knife.
No.
Is that Scotty Storm?
That doesn't even make sense. They already had predicted the eclipse. So if anything, you'd have to say that the knife was found. Like, what the fuck?
It's a knife.
Scotty Storm.
Try again. That didn't work. That didn't land. Do something else.
No, didn't work. Okay, give me a minute.
No, you said no knife and no stab wound.
Thanks for your honesty.
Like no sun, no moon, and then no, I don't know.
And just a positive claim, you don't need to say positive claim. A claim is a claim. If it's a negative claim, you just flip what you're trying to look for. Positive claim, negative claim. It's the same thing. You have to prove it.
Well, I mean, you're just looking at, like, I have no reason to do this because I have no evidence to support it. It's like, yeah, that's fine.
Yeah, so
you can do that. I don't care. But I'm looking at it as like, well, they are like fucking that long ago. They already figured out repeating eclipses down to the day.
That's
right?
why.
So we have plenty of evidence supporting the contrary.
Holy shit! And what's like one of the big themes throughout history, tracking the bodies, the heavenly bodies.
That's why
nobody until
you've ever done it.
Let me read it. I got you, bro.
Fuck, can I get something out?
Yeah, let him get it out. Go ahead.
Yeah, I'm just trying to say, like, this, you're saying, all right, there's no evidence to support this idea, therefore I reject it. It's like, fine, you could do that. But I'm looking at it from a different angle. I'm saying they had this shit figured out to 18-day cycles, down to the day. They knew the shit was going to keep happening. We're talking over. Not until Newton did they make any progress on this whatsoever. And I'm saying, yeah, that's not really believable because it's such like, there's so, you can see throughout history the fascination with the heavenly bodies.
Yeah.
Real quick. So
30 years ago, did you think there were going to be electric cars? Honestly. Like, did you think there would be chargers in every corner of the street?
We got we got the Sarocycle splits, the Babylonian astronomical diaries, and it has very, very precise predictions based off of literally just habitual observations. They could predict with very high precision when an eclipse was going to happen. It says the tablets were excavated primarily from the library of Ashurbanipal at Nineveh and later sites in Babylonia. They're written on baked clay and Akkadian using cuneiform script. Babylonian astronomers observed the eclipse patterns repeat roughly every 18 years, a period they systemized as the Saros cycle. By cataloging eclipse data over centuries, they could forecast future eclipses with accuracy. These records provide a foundation for later Hellenistic astronomical methods, including Greek and eventually modern eclipse predictions. And like I said, it was only surpassed in modern times by seconds. So they could predict eclipses up to minutes.
Oh shit!
That's when. Minutes. That's when they couldn't predict where. That's the whole argument.
Yeah, no, you don't know that. No, you don't know that. See, that's a positive claim, dude.
And you don't know
providing evidence of my claim. You guys are saying that they weren't able to.
Well, I'm just.
Again, how would they be able to? How would they be able to if they didn't know all of the locations in that plane?
Can I draw an analogy?
They have the path of totality for every location, because that's what it is.
Can I draw an analogy? And I'm not trying to run away on a
Wait. Can Lion answer that question though?
Yeah, so that now you're moving the goalposts. Originally, it was could they predict eclipses at all from their regional location? Now you guys are saying could they predict eclipses all over the world? That wasn't my claim. That's not the fucking point, right?
Dude,
the point is that they could predict eclipses.
Dude, the whole argument was
point
with
blank.
Totality. The whole argument was with path of totality. Which
yes. Including the path of totality from their regional location. In their location, they would know when that would happen. It's very significant when you had a completely total solar eclipse. Now you're asking, could they predict total totality in South America? That wasn't, dude. Obviously, they wouldn't be able to because they only had records of their location.
That's the point. That's what everyone's trying to tell you.
No, but if they were in South America, they also would be able to predict it.
Even Notanks told you. Like the point of the path of totality is regarding the location, the actual path of the eclipse on the land.
I've been fighting the whole time for their regional location. Obviously, that's the only thing that they would be able to observe habitually over hundreds of years. The astrolabes only work locally. You don't have a worldwide astrolabe.
We acknowledge that already. The point is there is a model for every location on Earth, every known location.
Yeah, all you need is like 8 or 12 astrolabes, and you got you can have the eclipses for everywhere on Earth, and all those astrolabes are planar.
No.
Yeah.
I mean, talk to Astronomy Live, who did it himself.
Dude, all you need independent astrolabes for your location because of your limit of vision. You have a limit of vision.
I don't see an issue. I think it's fine with with like what you're saying there with the celestial sphere coordinates being taken down to the center of Earth, and then observer dependent. We're always on top of the globe, quote unquote. So wherever you go with your astrolabe, wherever Astronomy Live says he is, his GP, he's going to imagine he's at that position, a straight tangent to the horizon, elevation angle from there, and it should align with a flat Earth. I mean, no problem.
It only works on celestial bodies that form a sphere. That's the thing.
Yeah, that's what they call it, the celestial sphere.
Exactly. And it only works on a sphere.
No, it's not on it. It's not on it though. It's in the sky.
Yeah, flat.
Yeah, but I mean, for you to be able to see that side of the sphere, you have to be under. You have to be under it, under the plane.
It's presumed though. No, because it's flat. They project it into a sphere just like they project it into a globe.
Why would they? If it's easier to project it as a plane.
Obviously, you don't have a measurement for either of these things.
So if it's easier to do it as a plane,
we went through.
If it's already a plane, why do they have to project it as a sphere?
You're gonna lay down.
I'm just asking why.
Take it like a man.
Why?
What you're gonna do?
No, I'm asking you why. What's the point?
Who told you it would be easier to project apparent positions, declination due to distance in a planar way? Why would you think that's easier?
Because if it was physically planar, it would be easier
instead of
doing a projection. So a projection is a way for you to show something in a certain way. So why don't you just show it what it is physically? If the ground was physical and the sky was physically planar too, you'd be able to compare them easier.
That's what they. Well, that is what they. That is in a way what they do. It's just that something goes away, it goes down, right? And they say, okay, look, it's going down. That's it.
What they
and that's
do
the projection. It's the way we see it. The way we see it it's apparent declination, apparent azimuth, and position in relation to our point, our GP, which is like you're on top of the globe, and you project it out all around you 360 degrees, and go from there. That's what I would do on a flat Earth. How would you do it?
It's a projection of an actual sphere.
I mean,
that seems like physically a sphere first, so they have to project it a certain way from its original form, which was a sphere. So,
like it works like as you've probably seen this thing called the celestial theodolite. It works, and within a certain degree, within a certain range, the celestial sphere, and it works best on a flat Earth when you just when you use the celestial sphere around you as apparent positions, declinations, azimuths, right ascension, etc. In its apparent positions, but only within that range. And you've seen in this thing called the celestial theodolite that it doesn't work when it's at its at its peak or at its extremity. So you just that's how. I mean, that would be the thing. That would be the best way to do it on a flat Earth. It's just how they're doing it.
Yes, celestial theodolite was retired because they were arguing on something that wasn't part of the model. They were arguing that the star would be occluded in the geometric location of the star, but we all know it gets occluded in the apparent. So it's fine.
I don't know. So I posted
well, let me just clear that thing.
Sure.
That thing up real quick is just that if the stars are occluding, right, because of the Earth curve, it would be going down, right? Earth curve blocking. If it's going away, it would start to slow down as it goes away. It wouldn't be a steady pace. That's all I'm talking about, and that's what they see in it.
Yo, so I think Dave made this, or Shane, one of them guys, and you have the NLEMA 15-year solar cycle, 18-year eclipse cycle, and you can see when they overlap, you could predict a totality and where it would happen. There's ways through geometry that you could do it over a flat plane. It's not that hard. It just takes a bit of
but it'll be a projection of the globe. If you make it a flat plane, it'll be a projection of the globe.
No, you think it's a projection of the globe. Really, it's a projection of the celestial sphere.
Oh, the celestial sphere, which came from a globe.
Yeah, but it's kinematically equivalent. You could just invert it. You can either use it on the ground or use it in the sky.
Because it's a projection.
Dude.
The globe says that the globe says that
it's a globe. It's a projection of the globe, which means
you can
all
say
the measurements are on a globe.
That's why you think you're on a globe, because of the sky, dude. We get that.
The globe says that the stars are flat. You know what I mean?
And you think it's flat because you're stuck 1,000 years ago.
So like the globe says that the sky is flat, right? And that you rotate away from it and it's just straight, right? And then you got these diverging things that apparently diverging at the equator because the sky is flat. Just flip it. You know what I mean? So now the sky is not flat. Yeah, in the globe, the sky is flat. Yeah.
That's the first time I'm hearing about it, but okay.
And you think the sky curves down while you curve? There's double curve.
No, what the fuck are you talking about,
bro? Just look at the image, bro. Just look at the image I posted, bro.
I'm driving.
You got spirals. You got the Fibonacci. You got everything.
I've seen that flower shit. That flower. Man, those cycles.
You got full moons, new moons.
Do you see a celestial sphere in the sky? Is that what you're saying?
Okay, so you can do the same thing. You can do the same thing if you were centered on Mars. You can do the same thing if you were centered on Mars.
Yeah, we know.
Yeah.
Real quick, do you think
Mars is a globe.
In the globe model, do you think that they use the sky as a circle in the globe model?
Wait. So let's go back to the flower patterns that you guys were talking about. Whether it's geocentric or heliocentric, it doesn't matter. They both work, right? But they both are globes. So using that argument, you're arguing for the globe.
No, because the thing you don't understand is, bro, it's because of the spherical nature of our vision of the sky itself, the way it's projected to our eyes. You guys have, you reverse engineered a globe model, but actually if you actually create an astrolabe for your local geography, which its limits are your limit of vision, and then all you have to do, as soon as you reach your limit of vision, you make another astrolabe and another astrolabe until you map the entirety of the world. All you need is like 8 to 12 astrolabes put together, and you have there you go. It works on a flat surface, no problem.
On a projection of a globe, though. On a projection of the globe.
The globe is in the sky, kid.
You don't need a globe, dude. You don't need a globe at all.
Yes, you do. Yes, you do.
No, you don't. No, you don't. No, you
How
don't.
would you follow the path? How would you follow? Okay. Wait. Before you go, how would you arrange the land formations on the Earth?
He ain't going nowhere. He's never leaving.
For the path. How would you do it?
Yeah, so you would, in the astrolabes is as if the stars are coming from underneath the Earth, but they're not actually.
About the path. We're talking about the path of totality.
Well, that's what I'm trying to explain to you. So when you look at the right ascension and declination of the luminaries, or even the sun and the moon, when they move up and then they set, right? It looks like they're going underneath you, right? Or they're popping up from underneath you, but they're not actually doing that. If you were to follow the sun or follow the moon, right, on its orbit, you would notice that it's not actually going underneath you. But yet, the way that you plot it out on an astrolabe, it's as if it's rising above the horizon. So
no, Lion, what I'm asking you is how you would pass it on the ground.
You guys think you're on a globe. Hold on. You guys think. Hold on, bro. Hold on, bro. You guys think you're on a globe.
Hold on. He's about to insult you.
But all you have to do is project it like it's actually a globe. It doesn't mean that you're on a globe.
That's the point. That's the point. The only arrangement of the land would only work if it was on a globe. If it was a projection of the globe. Yes, the path of the light can come from the bottom of the earth. Okay, fine. That's fine. But the path that it follows on the surface, how would you arrange the land formation to have it accurate?
I already told you, bro. In astrolabe, the ground is planar, the sky is curved, dude.
No, I'm asking you about, like, if I was in South America right now and my cousin was in the Philippines, how would you lay out the land for it to show an accurate eclipse, the path of totality on the ground? How would you?
I'm not sure. I'd have to figure that out.
Because you have to project the globe. That's the thing. That's what I've been trying to tell you.
No, you don't have to predict. It only works. An astrolabe, dude. Go look up an astrolabe.
Yes. But for you to be able to confirm that on the ground itself, you have to have a way to verify that on the ground. How would you do that?
I don't know what you're asking me, bro. An astrolabe works just fine, and it's planar surface, spherical sky. Or hemispherical sky.
Like that's what we like Doza. That's what we call like the thing. That's what we call the ground, the GP. It's like I'm not circular reasoning in a bad way, but that's like the definition. Like, well, how fast are you going? Well, it depends on how much time it took you and what speed you were going. That's what I mean.
Okay.
Like, and
so
the distance between GPs, what distance you went and what speed you were going. That's
if we projected those GPs, if we projected those GPs after you've gotten those astrolabes, what would it form?
What form? But the point is that
it would only form a globe. It's no tank. That's it.
No, it's not. No, it's not, bro. It wouldn't form a homogeneous globe. Actually, no, it wouldn't, because it's completely dependent on your observations of the sky at different locations. You guys have stitched all those observations together into like this homogeneous globe, and you think that's reality. That's not reality, dude. It's pragmatic. It's useful, right? It's useful to make predictions and travel, but that's not reality, dude. The reality is that it's observer dependent, right? You have to stitch it together and make this conceptual model, dude. But that's all it is a conceptual model.
But it works.
It has utility.
It works to the second. And if you go to that location, it'll give you the exact answer you were looking for.
That location is.
It doesn't matter.
The only way that would work is if it was on a globe.
That is what the location is. The location GP is the correlation of your angle of the star. You think that's its definition. That's its definition. You think it's like a coincidence or a coinciding of two things that are separate and distinct. No, that's the definition.
So if you put the map on those GPs,
that's it. That's its definition of a map.
What would it look like?
What would it look like?
That's it. If you put a map on those GPs,
it would look So if you were going to be honest with yourself, right, and just draw what you've seen independently, right, of whatever model you think the world is, you would have multiple hemispherical domes over the surface of a planar Earth.
No, that's just a way for you to
hemispherical domes.
That's just a way for you to say your limit of vision or your curved visual space. That's not a thing. You guys just made it up.
No, you would have multiple hemispherical domes. That's what we observe because of our
Light
limit of
enters
vision.
through lenses parallel.
What? Carolyn?
Like you guys, no, light enters your eyes in a parallel form. That's how it works. There's no curved visual space.
I don't know about that. I don't know about that. That seems weird.
We just talked about it yesterday. The other day with Rudolph, dude. What about, okay, now since we're talking about eclipses, how come the moon's shadow shrinks to 300 miles wide during the path of totality, while the moon has like a diameter of what? 3,000 miles, 2,000 miles, dude? How's that possible unless you have light converging?
I know.
The umbra.
Look it up. Look it up.
Yeah, it actually says that, well, you know, it's not perfectly parallel. It converges ever so slightly. So either you have parallel light rays or convergent light rays. Which is it?
Yeah, no shit. It'll converge slightly. It's going through a lens, but the light itself is parallel.
It's not parallel, dude. If you got a diameter right of 300 miles, dude. When the moon, how big is the moon again? If it was parallel, it would match the shadow of the umbra of the eclipse would be equivalent to the diameter of the moon. It's not. It's significantly smaller, dude. 300 miles wide. You guys are ad hoc that post hoc rationale, and you'll figure out a way to smuggle that into your model and make it work, like you always do, like you did with the Michelson-Morley experiment.
Dude, the name of the Michelson-Morley experiment is literally light through the luminiferous ether. You guys are the ones taking it and fucking turning it upside down. What's the name of the journal?
I know, but inside the Michelson-Morley experiment, there was a instrument that should have been able to measure the orbit, and they didn't.
That's not what they were trying to do, though.
I know it's not what they were trying to do. I know that's not what they were trying to do. It was there nonetheless. It was the measurement of us not orbiting is still there. I realized they weren't trying to do that.
Does it disprove the spin?
No, it was the orbit.
So we cannot be orbiting, but we can still be spinning.
According to Michelson-Morley?
In general.
I'm not sure. In general, I would say no. Do you have any science showing that we're rotating? We did the Foucault pendulum earlier. Do you have anything else or that we're rotating?
24 hours time.
Yeah, but you don't know if the sun's moving or we're moving. We remember the PhD, highest level of PhD-ness?
Yeah, I remember.
Like, we don't know if we're moving, the sun's moving. They never know what's moving.
Okay,
Like, I didn't make that up. That's just how it is.
I had this thought experiment with Beast, but he didn't answer me. So, do you think, as humans, you'd be able to detect 4 degrees every minute? Is that what it is? Would you be able to, Jeremy? Hello?
Yeah, what was the question?
As humans, we get dizzy when we stand up.
So if you were to be spinning 4 degrees a minute, or whatever the Earth's spin is, if you were on a chair, would you feel it?
It's 15 degrees an hour.
Oh, 15 degrees an hour.
You definitely feel 4 degrees a minute. 15 degrees an hour, would you feel that?
15 degrees an hour, yeah.
I don't know if you would feel that or not.
So how would we detect the spin of the Earth if you can't even feel you doing that on a chair?
Flight times would have been shortened too if the world was spinning.
I don't know. What was the last question?
How would you detect it?
If you're rotating,
if you can't even feel it on a chair moving 15 degrees an hour.
Because that's minuscule, but if you make that a billion times bigger, well, 1,000 times bigger, you'll definitely feel that 15 degrees.
It's still moving 15 degrees. That's not how exponential works.
Yeah, but there's a difference between 15 degrees when your rim velocity is 1,000 miles an hour versus, a fraction of a mile an hour.
But is it 15 degrees on every point? Even though it's 1,000 miles in the equator and 0 miles on the poles, it's still 15 degrees per hour.
Yeah, the angular velocity doesn't change. The tangential speed changes.
But you're just talking about the graph. That's not how spin works. That's not how you'd feel the spin. You'd feel the spin.
I already told you can't feel it.
Exactly. So how would you detect it? If you can't
exactly,
feel it,
dude, you're telling us it's moving, dude, but you can't even feel it. So how do we know it's moving?
Because we have evidence of satellites. We have evidence of leaving the reference frame.
Dude.
We have evidence of that.
Immediately went to space, dude. Immediately went to satellites.
Yeah, because that's the only way. Ask Jeremy, what would be the only way to detect that slow of a spin? You have to.
So we have to trust you that it's spinning, even though we can't feel it spinning.
No, you have to leave the reference. No, because you have a lot of other things that comport to those evidences. You have your phone. You have your satellite phone. You have
satellites.
You have so many things.
What does satellites have to do with the ground spinning, dude? Come on, bro. You could do better than that.
It left the reference frame. It left the reference frame, and it can show.
It's like saying, the Earth is spinning because Mars, dude.
No,
anything that sticks.
No, Lion. Evidence of spin is because there was a camera outside of the Earth. That's the evidence.
And
validate that.
Did you ever read Einstein's papers?
Terrestrial.
Did you?
We can't detect it terrestrially. I know what you're talking
we talk to Globers all the time. You can't know what's actually moving, dude. There's no absolute motion according to Einstein.
Einstein said you cannot detect the motion of the Earth terrestrially on Earth.
Yes, that's correct.
No. Einstein said there's no absolute motion whatsoever. There is no
absolute motion,
whether you're on Earth or whether you're in fucking the International Space Station.
They always go to Einstein.
No, see, Lion, you like to bring these conversations into whole different topics. You like to cry about everyone.
You're the one that brought up satellites, dude. Now we're here, dude. Don't cry.
No, we're talking about
Einstein said there's no absolute. Dude,
I'm talking, bro. Let me finish.
You definitely paused, bro.
Brought the non sequitur. Right. We're talking about the motion of the Earth. And the perfect proof of evidence, or the perfect evidence for motion of the Earth, are satellites. Because there are people who have launched satellites, even independently, and can prove that there's motion to the Earth.
Can prove? How? Can you validate what they said? Can you actually
look up Artemis 2 and see the spin? Look up Artemis 2. That's
Einstein said there's.
Can you validate?
He instantly changes the topic.
Your priest said that there's no absolute motion. There's no
preferred
reference
my priest,
frame.
Bro.
You understand what that means?
What you like to do?
No, this
Lion,
is
he's not a priest.
Einstein.
Dude, are you just freaking out again? You just want to shift the conversation to another topic?
Doza, you're appealing to a law of nature violating space.
Oh, here comes the actor talking about meta again. Stop it. I just got home too.
Doza, you are appealing to a second law of thermodynamics violating space vacuum as your proof of Earth spinning.
No nonsense.
Okay,
I'm not.
You can just watch the live stream and see it rotating.
Yeah, the space vacuum has nothing to do with the Earth rotation. Sorry, nothing at all.
And it disproves that you have satellites floating in this said vacuum.
It's
Fine,
incorrect too.
You could probably do this, right? You could probably do this. Now, can you please validate all that information that you're getting from that whatever Artemis project or whatever, or satellites you're saying? How are you going to validate that? Verify this information is actual?
I'm gonna build myself a rocket and go to the moon and validate that their pictures were true.
But if you do, you're a liar.
Yeah. What about the what is it, the Himawari 8? Takes a photo every 10 minutes and the weather patterns match any model. Any local what? Use a model. Use a fucking camera on a satellite. Takes
No,
a photo
they
of the Earth
use
every
a
10 minutes
model.
and sends it down. And you
It's
can
in-
intercept that picture as it comes from the satellite. You can intercept it and get it before it's gone to freaking, the Zionist fucking headquarters where they edit it and then release it to the public. You can intercept that image directly from the satellite.
Unfortunately, if I've actually gone through their FTP, their file transfer
Not
protocol,
FTP,
their
this is
files.
before FTP,
Stop.
Elbow.
Listen. Stop. And I've gone through their pages, and they actually have they use the Blue Marble 3D model to create those images.
No,
As a matter of fact,
they
you
don't.
actually download
Post
the images
post
that
the
they have.
FTP
Oh,
link.
wow.
Post the FTP link.
That is
Elbow,
over.
post the FTP link so we can show you
that. Well, then I
that
have
it's
to look
not
for
the
it.
Himawari, and you're saying it's the Himawari 8.
Yes, Himawari 8. Mm.
Okay, I'm gonna bet that you're not gonna find it, and when you do, it won't be the Himawari 8.
Yeah, because the Himawari 8 has an FTP fucking.
This is like
Connect on
2015
port
conversation,
21.
right?
Fucking beautiful.
You understand
I
this is
do, and
2015
I had the
conversation,
same.
right?
I had this conversation in 2015. So go ahead and post it, and then we'll see
And
how
I
this
actually
goes.
had those information in that FTP.
Okay, let's post it, and we'll see.
Okay, and once you provide evidence of that, this information that you have from the satellites can validate what you're saying now about the Earth rotating as well. I would find mine, but you have to go find yours. How are you going to validate?
Well, you could validate the Earth rotating with a lot simpler than that. But okay, go ahead.
Just a bit earlier, you were talking about not being able to feel the spin. Do any of you know what the human body can detect as far as forces go and what is generated by the rotation of the Earth?
Yeah, we get it, dude. The vestibular system wouldn't be able to pick it up, but still, the burden of proof is on you guys.
Why do you keep saying we can't
That
feel
sounds
it?
like a
Why
personal
do you
problem.
keep saying we can't feel it when you know you can't feel it? Even if it did exist, right? You're saying it doesn't.
You're presupposing that it's moving. You're presupposing that it's moving. That's the point, dude.
You can't
Can you
feel it
imagine
when
if
you
we
know
actually
you
feel it?
wouldn't be able to feel it.
You can't presuppose that the Earth is moving.
Man. Yo.
You
One
understand
at a
that
time,
right
guys.
now.
Put me in line,
We're
Jeremy.
right
Put me- I
now.
want
we're-
it on
He
the
asked the
list.
question. I went to answer it,
Hold
and
on.
people just started spurring.
Yeah, true. You know, right now we're at an impasse, right? You can't validate your claim about the Earth rotating. All you have is what you think is happening via some other third party that you can't validate.
No. You can do it
Let's
yourself.
get Phinky in there. Hold on, Paige. Let's get Phinky in there. He's in line.
Bob Nodell did it.
I just want to validate what Roundhound said. I think it's disingenuous to say, why don't we feel it when you know full well that the vestibular system isn't capable of feeling it? That's a great point. Thanks.
It's not a great point. You're appealing to the vestibular system to prove your point, right? When your point has never even been proven.
Yeah, if I told you there was invisible unicorns, you just can't detect them, but they're there.
Yeah, go ahead and publish
You guys
that,
wouldn't
Jeremy.
go. You wouldn't go for that. You wouldn't go for it. You'd be like, no, there's no way.
No,
Yeah, we just can't see them. We just can't see them. They're so they're invisible. We just can't see them.
Therefore, it's not happening. The claim is you can't feel it, therefore it's not happening. And we just established it. You know you wouldn't be able to feel it regardless. So why do you keep saying we can't feel it so we know it's not happening?
That was like Jeremy or someone. I would like one. Hey, could one of you guys? Could one of you guys please publish your invisible unicorn theory? I'd like to see that. Go out, send it out for peer review. See what happens.
I think it's insane to say that you wouldn't feel it. Like I feel a tick crawling on me. I feel dizzy when I stand up sometimes. Like you would feel it.
I think I could spin you slow enough at 15 degrees. I could probably, if you spun at 15 degrees an hour, you probably wouldn't be able to feel that.
Tests have been done. We know what the human body can feel. Okay,
You
it's
see,
not
when
not just a conjecture. We know what the human body can feel, and we know what the rotation of Earth generates, and it's 10 times less than what the human body can feel. You got no hope of feeling the Earth rotate.
One of the things they put you in pilot training, one of the things they put you in is called a Barney chair, where you spin around. And what happens is when you start spinning around and you're blindfolded, the ears, the stones in your ears stop. They stop feeling acceleration. So in the middle of the spin, it actually feels like you're not rotating. Then when they slow you down, it feels like you're spinning in the opposite direction. Google it. It's called Barney chair. BARA.
All right, so we all agree. All right, we all agree you can't feel it. Okay, what's next? Now what?
But there's 4 wobbles.
We don't all agree to that.
Yeah, there's 4 wobbles. I think
Who thinks you can
wobble.
feel it? Who thinks you can feel the?
Moto.
Who thinks you should be able to feel the rotation?
Oh, well, yeah, the wobbles would take the wobbles would take thousands of years to do a complete circuit. Yeah, you can definitely feel those.
Any change in direction.
Again, look up Barney chair. or you spin yourself in, once you stop in a constant spin, your ears stop feeling it. It's weird, but it works. You want me to Google it for you? Because you guys probably won't do it.
That's not even the point. Even if you can feel a spin in a chair, but if you sit in a chair and you spin less than your vestibular system can detect, you're not going to feel it. It's not that hard of a concept.
But what if is it an ellipse or a perfect circle?
Oh my God! So the circle
doesn't matter.
What if the Earth just isn't spinning?
0.3 degrees, the 0.3 degrees of eccentricity in the orbit, we're going to feel that for sure, right?
Make a prediction. What if the Earth isn't spinning? Then what should we see?
What do you mean?
Like, how can we
That's a palm reader gypsy fortune teller prediction.
It's not spinning, dude. I would expect to not feel any spin, which is exactly what we feel. No spin. You're saying, oh yeah, it's because the vestibular system is not sensitive enough. Okay, so still we don't feel any motion.
When it comes to things moving in space or just anywhere, really, you guys have no argument. Like I said, the highest level PhDs tell you can never know what's moving. How can you argue for Earth rotation with a mainstream physics model like that?
Yeah, I don't think they struggle the way you think they do with motion.
No, I've been over it with PhD physicists. They don't know what's moving they're struggling, believe me, way harder than I am. I believe you can know in certain situations absolutely what is moving, like a tree in a car. You know what I'm saying? We know the car moves. We make the car move. We're not in Lord of the Rings. PhDs are struggling with the car and the tree scenario.
The car definitely moves relative to Earth. I don't think they would disagree with you on that.
We're not talking about relative motion, dude. We're talking about absolute motion within relative motion.
Yeah, the tree's absolutely still, and the car absolutely moved towards the tree. Like, we know how trees and cars work.
Well, like, people can be in a hurricane, trees move towards cars that are still. So it only makes sense relative to
We would definitely know if we were in a hurricane, though, right?
I think so, yeah.
Yeah. So the thing is, you can have
we would probably know if there was a hurricane moving the tree to the car,
right?
Moving the car to the.
Yeah, but if a unicorn threw the tree at your car,
Pinky. Absolute motion does not debunk relative motion, right? Relative motion does not debunk absolute motion. You can have both in the same system. What we're talking about is relativity. Is relativity.
Where is the absolute reference frame? Please tell me. I'd like to measure it.
Well, in my case, it would be the Earth. It's the absolute reference frame. Stationary.
Okay, so everything moves absolutely in reference relative to Earth. That's your absolute frame. All right.
Yes, but the thing is, even Newton believed in relative motion. He also believed in absolute motion. He just thought that
there's no absolute reference frame. Earth is not the absolute reference frame.
Okay, but you understand that, like, you can have relative motion.
Space would have to have one. Space would have with like the galactic frame would be the absolute.
No, we're not denying. Hold on, we're not denying. We're not denying relative motion in general. Just like a car passing you by on the highway, you're doing 65. The car's passing you by, and then it looks like you're actually processing backwards. I get it, dude, but we're not talking about that. We're talking about relativity, dude. We're not talking about relative motion. We're talking about relativity.
Which in its name says there's no absolute reference frame.
Right. In relativity,
all the sort of relativistic stuff can be explained through pure mathematics, just in the same way, like 2 + 2 = 4. It, can be rearranged to 4 - 2 = 2. Like, you can rearrange the elements, but doesn't the fact that, like, spinning objects exist in reality kind of debunk the whole idea of, like, every framework is equally justified? It's like if you spin around a circle, during nighttime, right? If it's during nighttime and you see the stars around you, you spin around a circle. Can you really argue that the stars are the things spinning at that great distance they appear to be, and that you're the one actually staying still and not spinning? Even if you think you're spinning, it's like this. It's actually, there's a chance that the stars are spinning. That would break the speed of light. At any certain distance, it's like for them to actually be the ones rotating around the observer, and the observer is standing still, even if he thinks he's spinning. It's like the star spinning around him. It's like, no, that makes absolutely no sense. That the stars are the ones spinning around him, and the kid spinning around in a circle is actually the one staying still. It breaks all the laws of logic and physics.
It doesn't break logic, dude. What are you talking about? And we don't know how far the stars are.
The hard part is they can't place stars in any absolute position anyway to make any claims about them, because everything's apparent.
As long as stars are at a certain distance, if you just spin around in a circle, looking at the night sky, you see them moving in your frame of vision. And then do you really want to argue that they're the ones moving potentially, and that the guy who thinks he's like spinning around a circle is actually staying still? Obviously not. The things would have to be traveling at like 3 million times the speed of light.
They don't. Yeah,
for them to be
given
the
their
ones
distance. Yeah, given the global distances. How do you know that the stars are light years away, dude?
Given any distance past 5 miles, they would be breaking the speed of light by 10-fold.
How do you know that? You did the calculations?
Yeah, pretty simple math.
So you did the calculations? Because I haven't done them, but you're saying that if the ceiling was 5 miles away, that they would break the speed of light.
Yeah.
That don't seem right to me.
A human being. Do you understand how fast like an ice skater, ballerina, whatever can spin? They can spin pretty fucking fast.
Bro, listen, just from the top of my head, I haven't done the calculations, bro. I haven't done the calculations, but the sun is 93 million miles away, right? And it has also 15. Both the sun, the moon, and the stars spin around at 15 degrees per hour, dude. You're saying the sun's breaking the speed of light?
No, he's talking about spinning in your chair.
Exactly. I'm just saying, if you are just a human, you know how you can just spin in a circle like on your own 2 feet? Maybe you did this as a kid once or twice before as a child, right? You just spin in a circle, right? So even if the stars are even just 5 miles away from you, the rotational speed that you just as a little kid can just stick your arms out and spin around a circle at a rotational speed of like 6 RPM. Or not RPM, RPS, 5 rotations a second or whatever, 3. It doesn't matter, right? Just anything like that at a 5-mile distance, it's obvious that it would break the speed of light for the things at even 5 miles away to be the ones actually circulating around you versus you to be the one spinning.
I don't get what you're talking about.
That already makes things 5 miles away.
Nothing's spinning like that, dude. It's spinning at 15 degrees per hour. It takes 24 hours for a complete rotation. What are you talking about, dude?
I don't know how you're this confused.
I'm trying to make sense of what you're saying, dude. Can you break it down? Is it even comprehensible, or is it just me, or is what he's saying coherent?
No, it makes sense.
You don't understand the dichotomy of one thing is spinning and the other thing is stationary.
You're saying at 5 rotations per hour, even though the sky's doing 1 rotation per day.
You really just don't get it, do you?
No, just please try again, dude. I really don't.
I'm not going to try. Someone else already said, yeah, he's making sense, and you just don't get it. So that's as much effort as I'm willing to put into this.
Well, the sun's 93 million miles away, and it rotates at 15 degrees per hour, the same amount as the stars. Is the sun breaking the speed of light?
I was only saying, spinning disproves relative motion.
I don't know, dude.
Does
anybody understand what he's saying? Please help me out. It might be me, dude. I might be retarded. I need somebody to explain it to me because I really don't get it.
That's definitely. I agree with that. The first thing you said, I agree with.
I'm trying to be humble and charitable. I really don't get what he's saying.
He's saying when you get given two explanations for what's going on. If you have a person that's sitting in the chair, you could argue technically that they're the ones staying still and that the sky is rotating at 3 revolutions per second. But we can all look at that and say that makes no sense because that would break laws of physics for the sky to be spinning that fast. He's making an argument for just one of these explanations makes way more sense than the other one.
Oh, wow. Thanks, man. Somehow you got it.
Still don't get it, dude. I don't know how that debunks anything.
If you didn't get what he just said to you, then I'm not going to try. That was really great, man. Thank you for steelmanning me so well.
You're welcome.